Hi everyone, I think we should be live now. So if you can hear as well as see me, then you can just punch in a yes in the chat box for me to understand. Yeah, am I audible and visible to all? Yes. Okay. Audible and visible to all. That's good. And then we can start. Okay, great. So today's question was a good one. This was the question. I hope you guys knew about it. You guys read it. So did you give a try to it? How many of you tried solving this question on your own? If you did, you can say yes. You can also feel free to write your approach, whatever logic you used, whatever algorithm you used, and then we can begin the discussion. Okay, so far Rachit Shukla is saying that he was able to solve it. Okay, awesome. Would you also want to talk about your logic? So in the meantime, others, those who did not get time to read the question can read it along with me. So it says that you are given an integer n, and now we have to break it into sum of k positive integers where k should be greater than equal to 2, and we have to maximize the product of those integers. So this is the most important requirement, this whatever I have shaded. So basically you will be given a number. So let's say your number is 100. So you should split 100 as a sum of some other integers. For example, 100 can be written as 60 plus 30 plus 10, right? Because 60 plus 30 is 90 plus 10 is 100, right? Now the product here that you will get will be 60 into 30 into 10. So what we have to do is we have to maximize that product. So all of you can understand that the number 100 can be split into sum of multiple numbers. I mean, I can write 100 as 50 plus 50 also. I can write 100 as 10 plus 10 plus 10 plus 10 and so on also. But eventually what I want is that the product of those numbers should be maximal. I would say a really important thing to keep in mind over here is that the value of k should be greater than equal to 2, which means that you need to split the number n into at least 2 parts. So that means if you have been given a number n which is, let's say, equals to 5, now you can say it quite clearly that hey, I can represent 5 as 1 plus 4. I can also represent 5 as 2 plus 2 plus 1, and I can also represent 5 as just 5. So if I represent 5 as this, the product of the numbers that I am getting is 1 multiplied by 4, which is equal to 4. And if I do something like this, then also luckily what I am getting is 2 into 1, which again fortunately is 4. In this case it is just 5. I would say this is not allowed. You cannot split a number into just one part. You have to split it into 2 or more than 2 parts. So this is another important thing to be kept into mind. So I hope you guys could follow me on the problem statement. Could you? You can just say yes if you feel comfortable with the problem statement itself. Yeah? Okay. Great. So some of you have mentioned your approach. It looks like some recursion based solution that you have tried to write. If negative numbers, so see in this case, if you look at the constraints, it says that the value of n is in between 2 to 58, so you don't have to worry about negative numbers. That's the first thing. The second thing is you also don't have to worry about very large numbers, because when I saw this question, then the first thing that came to my mind was that hey, what if the product of those integers does not fit into a long or long? So in that case, what do I do? So the question simplifies it by giving you a very small constraint, the constraint says that the value of n is only in between 2 to 58. So these are small numbers. So it's guaranteed that their product will not exceed the maximum possible value of a number which is supported by your language. Let's say the maximum value of long, right? Okay. However, keep it in your mind that your overall answer, which is the maximum product, that can be very large. Of course, because here it says that whatever you have to return is just an integer only. So I can assume that, hey, it would fit inside an integer. It's a predefined function template. So no worries, right? But just to be on the safer side, if let's say you were the one who had to define this function, you could otherwise have chosen a long or long, basically to safeguard things so that there is no integer overflow at all. Right. Cool. So I can see that Rachit has mentioned a solution and Harsh has mentioned a brute force solution. So what are the different things that we can do here? Let's first have a look at some examples. Can you see why the answer to 10 is 36? Because this 10, they have shown that you can take out a pen and paper and you can just try expressing 10 as a sum of multiple natural numbers. Now there you will see that this is the distribution which luckily gives you the maximum product, that happens to be 36. I would say when nothing clicks, let's think about the brute force approach. How to think about the brute force approach over here. In this particular case, when you look at this question, I would say I have got elements of choice. This is a very, very important thing to figure out in a new question which is given to you. And it has got nothing to do with, I would say, data structures or algorithms. It's rather just a concept, because many a times we face a problem in which we have multiple choice at a certain time. Okay, what do I mean by multiple choice? You might ask me this question. What do you mean by elements of choice? So I would say, let's say somebody gave you a value of n that happened to be 4. That means that person wants you to split this number 4 as a sum of k positive integers, where k should be greater than or equal to 2. Now, basically I have to choose so many numbers, right? So how many choices do I have for my first number? In how many ways I can choose my first number? Can you guys tell me that? So I can say that, hey, my first number could be 1. It could also be 2. It could also be 3. But guys, can it be 4? Can it be 4? The answer is no. It cannot be 4, because the question strictly says that the value of k should be greater than or equal to 2. So the number of elements in which you split it into should be greater than or equal to 2. So if you choose your first number as 4, there is no second or third number that you can choose. So this kind of choice is not allowed, right? So your first choice could either be a 1, or it could be a 2, or it could be a 3. Is this point making sense to everyone? So this 1, 2 and 3 were the elements of choice for first element in the sum that I am willing to produce. You guys can just let me know whether this point made some sense or not. Now, whenever we encounter a question in which there are elements of choice, what is the most natural thing that comes to your mind? What kind of approach comes to the mind? Tell me. I know a lot of you would be learning data structures and algorithms from Renaissance, and it's very clearly taught over there. Yes, recursion. Recursion is the tool which can be used to simulate the problems where you have got elements of choice. Now, guys, this can just keep going on and on. So I can say that, hey, like once I have, let's say if I stick to this particular choice, if the first number chosen by me is 1, in that case, what is the remaining value of the number? The remaining value of the number will be 4 minus 1, which is 3. If the first choice is 2, what will be the remaining value of number? It will be 4 minus 2, that is 2. In this case, it will be 4 minus 3, that is 1. So I would say that, hey, if I want to know the answer for n equals to 4, then that depends upon the answer for, I would say, 3 things. The first thing is answer for 4 minus 1, which is answer for 3. I would just write it as A to make things look a little cleaner. And it depends upon answer for 4 minus 2, that is 2. And it depends upon answer for 4 minus 3, that's 1. So basically, you know why I have written this? Why I have written this? Because see, corresponding to all the 3 choices that you had, if let's say you decided to choose 1 as your first number, then what is the remaining value of your number? It is 4 minus 1, that is 3. Similarly, if you decide to choose 2, the remaining value would be 4 minus 2, which is 2. And if you decided to choose 3, the remaining value will be 4 minus 3, that is 1. Correct? That is the reason I have written this thing. Now think of it in this manner. If somebody magically tells you that, hey, what is the maximum product that you can get if your number is 3, and what is the maximum product that you can get if your number is 2, and what is the maximum product that you can get if your number is 1, then probably your job is very easy. Then your job is super easy, isn't it? Because think of it in this manner. If I know the maximum possible product that I can get by splitting 3, and let's say if that value is P, and I also know the maximum possible product that I can get by splitting 2, and let's say that value is Q. And if I also know the maximum product that I can get by splitting 1, and that value is R, then can you tell me the value of answer of 4? Answer of 4 would be max of 3 items. The first item will be P multiplied by 1. Why I am saying P multiplied by 1? Because you got to this particular situation by picking your first number as 1. If you picked your first number as 1, that means it needs to be multiplied with the product that you are getting from here. Now if the product that you are getting from here is P, then inclusion of 1 into that product will result into a value of P into 1. With the same logic, I can go on to say that, hey, if the first number chosen by me in this branch, this particular branch, was 2, and the maximum product that I am getting from here is Q, then inclusion of 2 will give me something that is Q multiplied by 2. Similarly, if I talk about this particular branch, the number that I had chosen as my first number was 3, and let's say the maximum possible value that I am going to get from here is R, then the answer will be R into 3. Now, whatever is the max of all these 3 items, that is going to be the value of answer of 4. So I can see that there is a clear-cut relationship between answer of 4 and answer of 1, 2 and 3. You know, this is something which is, I'm quite sure that you guys must have been shared some YouTube videos to watch first, where there are some fundamental concepts of recursion and dynamic programming that I have talked about. So it says something exactly as this. What it says is that there is a big problem, and if the solution of that big problem depends upon the solution of smaller sub problems, then this is the nature of DP. This is the nature of, I would say, forget about DP for a while, this is the nature of recursion, because this is what you do in recursion. You say that, like, what do you do in Fibonacci number? You say that nth Fibonacci number is equals to f of n minus 1, which is n minus 1th Fibonacci number, plus n minus 2nd Fibonacci number. We are doing the same thing here. We are saying that answer of 4 has a dependency on answer of 3, answer of 2, answer of 1. So if we somehow calculate these, I'll be able to calculate answer of 4 also. Is this point making sense? How many of you are absolutely clear with this thing? Right? Okay. There is just a one important thing that you guys need to understand. And let me tell you what. When I told you how many choices we have for n equals to 4, I very outrightly told you that we don't have a fourth choice. I mean, we don't have a fourth choice of keeping 4 as the first element. Forget about choices like having 5 or 6, because in that case the remaining quantity will be negative and we don't want negatives, right? So basically the point was we can't have 4 over here. But tell me one thing. When you are trying to split this 3, can you split this 3 into just one part? Can we do that? The answer is yes. And why the answer is yes? Because the original question said that we want to split overall into more than 2 parts, 2 or more than 2 parts. So tell me one thing, here in the first branch, you have already split it into one part. When you say your first number is 1 or your first number is 2 or your first number is 3, that means you have already sucked one part of it. Now, even if you don't split it further, you don't split it further, you don't split it further, you're totally okay. So if somebody says that how many choices do you have for answer of 3, you can say that I have got 3 choices. I mean, I can have my first element as 1, I can have my first element as 2, and I can have my first element as 3 also. Now this is a very important point for you guys to realize. Are you able to? Yes or no? Right? So I would say that for the original n, for the original input n, I have to ensure that I do not make n choices. I just make n minus 1 choices as my first element. But for the subsequent calls, for the subsequent recursive function calls, you can have n different choices if this value is n, if I refer to it as n. Okay, now I would talk a little bit more about it over here. So think of it in this manner. Tell me one thing. What will be the value of a of 3? A of 3 means what is the best possible product that you can get by splitting 3 into 3 as a sum of multiple numbers. So you can try that out. If you have to split 3 out, what are the possibilities? It could either be 1 plus 1 plus 1, guys, or it could be 1 plus 2, or it could just be 3. Is there any other choice than that? No other choice, right? And which one of these is giving you the best possible product? This will give you 1 into 1 into 1, which is 1. This will give you 1 into 2, which is 2. This will give you just 3, and the maximum that is 3. So I would say that the best possible product from here is 3. Similarly, can you tell me what will be the answer of 2? So when you talk about 2, you can split it as 1 plus 1, or you can just let it be. Again, here this is giving you the best possible product, which is 2, right? And what will be the answer of 1? It will just be 1. Have to let it be as it is, right? Now what does it mean? The value of p is actually 3, right? And what is the value of q? It's 2. And what is the value of r? It's 1. If I feed these values here, this is going to be 3 into 1, this is going to be 2 into 2, and that is going to be 1 into 3. Now out of these, what is maximum? The maximum is 2 into 2, which is 4, and that is the answer for a of 4, right? So this is how it works. Did you see what really happened? If we knew the answer of all these smaller subqueries or sub problems, we were able to deduce the answer for the actual query or the actual problem. That was n equals to 4. The important thing to keep in mind was that here we just had 4 minus 1 choices, but here it was not 3 minus 1, it was 3 choices. My first element could be 1, it could be 2, it could be 3. Similarly here, similarly here. Now if you're wondering that whatever we did here, can we repeat the same thing here? The answer is yes. And that is what you do in recursion. You write a recursive code and get this entire thing done exactly like that. Okay. Okay, cool. So is this logic making enough sense to everyone? Can you guys follow me on this? Yeah? Okay. See, I remember having taken one class on recursion where I told you that there are 2 important parts of recursion. The first important part of recursion is recurrence relation. And I spoke about recurrence relation. Recurrence relation is this thing only, where you correlate a larger problem to smaller subproblem. What is the second important part of recursion? That is called as base condition or termination condition. Now tell me one thing, if at any point of time the value of number is 1, can we just return 1 from there? Can we do that? The answer is yes. We can just return 1 from there, because if you just have 1, there is no choice. You can just let it be like that, and that's the best thing that you can get, right? So I would say, let's say I want to get this thing done by writing a simple recursive logic. Then how do I go about it? I can probably first start off with my simple, super simple base condition, which says that if n is 1, just return 1 and enjoy, right? Okay. But if n is not 1, like let's say if the value of n is 4 or the value of n is 3, in that case I can make multiple choices. So let's say the value of n was 4, then in that case I'm going to make different choices. In fact, how many choices? 4 minus 1 choices, right? Now whatever answer I get from here, whatever answer I get from here, whatever answer I get from here, I have to pick the maximum of them, right? So I needed to find out the maximum of all these values. So if the value is n, I am going to be making n minus 1 different function calls, and from those n minus 1 different function calls, I will be receiving their answers, their respective answers, and I have to find their overall maximum. So what I can do is I can write a for loop, and that for loop will be responsible for making all these calls, invoking all these functions, and also updating the answer. So I can say that, hey, let's get started with an answer variable, which is, let's say, to start with minus infinity, L long min, right? Immediately after this, what we can do is we can just go ahead and start making the different set of calls, right? So what are the different choices that you had, guys? You said that my first choice could be to take 1 out, the second choice could be to take 2 out, like what we did here, 1, 2 till 3. And what is 3? It is n minus 1. So I would say I smaller than n. Mind it, it is smaller than n, it is not equal to n, I plus plus. Each iteration of this for loop is going to make a particular function call. Now when we are making a function call, what we are actually doing is that the first number that we are extracting out is I. If you extract out I, what will be the leftover value? If you extract I from the number n, the leftover value will be n minus I, correct? Okay, so I can say that, hey, what will happen is that now I'll have to recurse for the remaining value, and that remaining value is going to be n minus I. Now whatever answer I get from here, like you got p, let's say you got 3, then you needed to multiply that 3 with 1. What was 1? 1 was I. Like in this case, when you say you extract I, then you need to multiply that I with the best possible answer that you get from n minus I. So you need to multiply that value I with it, correct? And then you need to check if this value happens to be greater than your answer, then you got to simply update your answer. So what I should be saying is that, hey, answer is equals to maximum of answer comma the other thing, which is this. Okay, this is what we have. Clear to everyone? This was super important for all to understand. You guys can let me know whether you understand this for loop, because this for loop is the explanation to all the logic that we have discussed so far. Okay, great. This is nothing. This is just simple recursion. Okay, cool. Now, there is one thing that we find ourselves stuck with over here. What is that? Tell me one thing. I told you very clearly that for the original value of n, we have n minus 1 choices. But for subsequent values of n, like 3 or 2, which are smaller than the original n, we can just let them be. We can let the number be as it is. Now see, here you just have a single function, integer break, which is being used for the purpose of recursion again and again, again and again. So my question to you is, can you recognize whether the number that has been passed over here, does it happen to be the original n or not? Will you be able to recognize that? The answer is no. You will not be able to recognize that, because you need to have a logic in place that ensures that for the smaller values, when the function calls are made, we are able to let them be as it is. I mean, 3 can just let to be as it is, 2 can let to be as it is, 1 can let to be as it is, right? So there is no way to check whether the number that has been passed to this function happens to be the original input or not, right? So for that, probably what we can do is we can go ahead and write another function. We can call it func. And inside this function func, what I'm going to do is I'm going to just copy paste this entire code. Okay. Now herein, I'll be passing two things. There will be an original value, and then there'll be a value which is changing over the recursive calls, over the set of recursive calls. Correct? Now here, I can go ahead and write my logic. So I can just say that, hey, if the value of n is not equals to the original value, if the value of n is not equals to the original value, that means we could have chosen not to split it at all. If we would have chosen not to split it at all, then in that case, we need to consider it and we need to check whether our current answer is smaller than the value of n. Because you saw it, guys, like in case of something like 3, if you choose your first number as 1, the best product you get is 1. If you choose your first number as 2, if I rather write it like 2 plus 1 to make it more clear, the best product that you get is 2 into 1, which is 2. So I need to take hold of that case also where I do not split the number n at all. But I need to perform this check for sure, right? So in that case, I need to have this particular line written as well. And from here, I can just return answer for this case, right? Now what I can do is that I can just go ahead and return func of n comma n. You can see that the first number will remain unchanged, which is the original value, and because I'm making recursive calls, so I need to continuously keep on passing it without modifying it at all. The second number is being modified. That's it. Okay, so that's the overall logic. We can just try to run it and see if what happens. I think we need to fix something somewhere. Too many arguments to function call, expected n, and yeah, it's func now that we are calling. This is our recursive function, not the other one. One more thing, this function max, it either takes 2 integers or it takes 2 long. So this answer is a long, but this thing is an integer. The value of I is integer, the return type of this is integer. So it would be great if I just typecast it into long. In that case, this probably should be okay. The same thing here. Let's typecast this also to long, and then run it. I think we may not need this long at all. In that case, this typecasting would also not be needed. You can check that out. So it basically works well. I can just run it against some other set of test cases also. Let's run it for 2 as well as for 10, see whether it works. So it works. So far it works. Okay. So what do you think? If I submit this solution, will it work? Will it be all good? Let's run it for the largest possible value, which is 58. What happens if I run it for 58? You can see that it is giving me time limit exceeded. And can you tell me why it is giving me time limit exceeded? Because there are so many function calls which are going to be made over here. Okay. In fact, you will end up seeing that a particular function call that you made, that function call happens again. For example, let me tell you, let's say you wanted to solve for 5, f of 5. And to start with, you said that, hey, the first choice I have is 5 minus 1, that is 4. I also have 5 minus 2, that is 3. I also have 2. I also have 5 minus 4, that is 1. So f of 5 will end up making these function calls. Now think of it in this manner. When f of 4 is being triggered, f of 4 will also end up making a call to f of 3, isn't it? So f of 4 would end up invoking f of 3. It would also invoke f of 2 and others. So basically a particular function call will end up appearing again and again and again. So if you try drawing the recursion tree diagram, you will see that the number of function calls is almost exponential. If it is exponential, then for a particular value of n, if I consider a base of 2 or something like that, then the value could be very large. Okay, so in fact the base would not be exactly 2, it could be more than that. So if there are exponential number of function calls, you will definitely get time limit exceeded. Now in order to get rid of this scenario, we use the concept of dynamic programming, which says that if a particular problem has been solved, then do not solve it again. You just store it with you somewhere so that you can reuse it again and again. So it means that once we have figured out a value of, let's say, f of 3, the next time we encounter it again, we should not be recursively solving it. Rather, we should be able to just return it the way it is, return it the way it has been just solved. Now that particular concept is also called as memoization, where you use a memoization table and you store the solutions to the sub-problems. Have you heard of it? How many of you have some idea of dynamic programming and some idea of memoization concepts? You can just say yes if you have that. So if you have that, you will be able to relate to all of it pretty much, I guess. So what we can do is we can say that, hey, actually what we are doing is we are reducing the value of n. So if it was 4, now it is becoming 3, 2, 1. So it's reducing gradually. So we need to store the answer to n, n minus 1, n minus 2, all of those. So for that purpose, I am going to have a vector of probably long values. I'm going to call it answer. I'll give it a size of n plus 1 and I'll initialize everything to 0. Okay, and now I'll be passing this vector to this function. Okay, and I'll be passing it by reference. Why I'm passing it by reference? Because guys, if you do not do it, if you do not pass something by reference, then each time a function call is made, a new copy of it will be created. And if you are creating a new copy of vector or array each time a function is invoked, it will end up giving a time limit exceeded again. So better to pass it by reference if you do not intend to have separate copies across separate function calls, right? Okay, great. So now few things will change over here. What will be those few things? So you can see here that I initialized every item inside this thing to 0, correct? Every item was 0. So if I ever find out that answer of n is not equals to 0, what would it mean? It would mean that we have already figured out the value of it and stored it. So we can just return it the way it is. We can just return answer of n, correct? Okay. If this condition was not true, that means answer of n was 0. If answer of n was 0, that means we are encountering this problem for the first time. And if we are encountering it for the first time, then we need to solve it. So we would say that let's initialize answer of n to minus infinity. And then let's go on making all these function calls that we have. And of course here, this will be answer of n. And we would say max, this is equals to max of answer n, comma, the other value. And do not forget to pass your third variable over here, which is answer vector. And now, over here also the same thing will be done. Answer of n is equals to max of answer n, comma, that long of n, and finally we return answer of n. So do you see what has been changed in the current code and the previous code? The only thing that has been changed is that now we are doing memoization. We are doing caching basically. The moment we solve for answer of I, we are not solving for it again. We are, let's say we encountered answer of 5 for the first time. When we encountered, we solved it. And when we solved it, we assigned certain value to it. So the next time if func of 5 has been called, we will not solve it again because of this if check. This if check will ensure that we simply return it the way it has been found. So that's the idea. That's the overall idea. Does this point make sense? How many of you get that? Right? So, you know, the switch from recursion to dynamic programming is very easy if your idea of recursion is very clear. I would say the intelligent part over here was just of recursion. And just in order to optimize things, we perform memoization. This is the core concept of DP. Now let's run this code and see for ourselves what happens. There is some issue. Oh, this is not needed because we are already passing it over here. Okay, it works. So let's run it for something very, very large, which is 58. If you remember, for 58 we had got TLE using our previous approach, but here there is no TLE. Why that TLE is not there? Because of the idea of memoization. The moment we solve a problem, we cache it, we don't solve it yet again. Okay, so you can even submit it. And you can see it has been accepted. So this was one way. This kind of dynamic programming approach is also called as top-bottom DP. So quite literally I have to talk about DP in just this 1 hour window, which is not at all possible because they gave you a question which has one of its solutions streaming from dynamic programming. So I had to do it all. But if I have to really teach you DP, it is something that takes many classes. It takes some time to digest and understand, first solve some easy questions. So don't get demotivated if you feel like you're not able to get hang of DP, don't feel it is rocket science. Trust me, it is not. Trust me, it is not. So the first important requirement to be good at DP is that you should be very good at recursion, which is what we ensure, right? And after that, you start solving problems on DP and then gradually build things on top of it. But I would be a little curious to know from those of you who are beginners in DP and are currently present over here in this live stream, those of you who are beginners in DP or do not know anything about DP, could you at least relate even 50, 60, 70% of whatever we have done? Could you at least relate to the recursion part and little bit of memoization part? Was that clear in bits and pieces? So even if it was, I would say it's great. You were able to do a good job, because people usually find it very tricky to understand it in the first go, let alone when you have been given a problem which is of a good nature, I would say, over here. How many of you here already knew few things about DP, already had solved some questions on DP and knew how to deal with it? You can say yes. Okay, so if you knew DP and if you solved some questions on it, then I think it would mostly have been a cakewalk for you. Okay, I also wanted to talk about bottom-top solution, but I don't feel like talking about it right now because I'm not sure how many of you are very comfortable. You'd be comfortable with bottom-top idea only when you get super comfortable with it. So if you want, I can give you the best possible advice that can help, that can hone your understanding of DP. And let me tell you, DP is interviewers' favorite question, favorite category of question when it comes to assessing your problem solving skills. You will definitely be asked at least 1 or 2 questions in either your first, second or third round of technical interview if you are sitting for product-based companies. So this is something that you cannot skip at all, right? So if you feel you are a beginner, or if you feel you have learned it but you could not understand it well, the things were not in depth, I would say start by watching the YouTube videos that were shared on your community channels, on your community WhatsApp groups. Did you see them? How many of you got a chance to watch those YouTube videos which were shared by Kritika, I think, today in the morning? Okay, if you did that, that's awesome. If you did not do that, I would really want all of you to do that first. Go back, just watch those videos. It will give you some, good enough understanding of DP, and then you can correlate a lot after that, right? Cool then. So I think we can then stop it over here at this point. Let's see what question we get tomorrow. And I'll probably try arranging for maybe some 1 or 2 DP specific classes for all of you, if a lot of you would be interested, where we can help many beginners get kick-started with that. Okay, cool then. So if you want, just watch it over again and then try connecting the dots, if at all that helps. Yeah, cool. Bye and good night.